Good afternoon, and thank you for joining us for today's webinar, Indoor Air Quality Monitoring Strategies for a Safe Return to Work. My name is Christian Carlson, and I would like to go over a couple of quick housekeeping items before we get started today. During the webinar, you can submit questions at any time using the GoToWebinar question or chat options, and we will do our best to get to all of them if time permits. If we are unable to get to all of the questions during today's live broadcast, then we will follow up with you directly. We will also be sending out a follow-up email to all attendees that will include the slide deck and a link to the webinar recording. Next, quickly, just please keep in mind that you should consult with your legal department or advisor concerning the particular facts and circumstances we cover today as they relate to your organization. So Dave, if you could advance through the slides, I will go into introducing our presenters this morning. First, I'd like to introduce Dave Elam. He's the project director in the Air Management Services Group here at TRC. Hi, Dave, how are you?
I'm fine, Christian, thanks.
You want to tell the audience a little bit about yourself and your background?
Oh, yeah. So I've been working in the environmental health and safety field for about 35 years. My background is principally in the air quality area, but in the past few years, I've spent most of my time in the indoor air quality industrial hygiene area, and most recently in the sensor area.
Okay, great. Thanks, Dave. Next, I'd like to introduce Harry Neal. He's the director in our Indoor Air Quality and Microbiological Services Group at TRC. Hi, Harry. Thanks for joining us today.
Good afternoon, everyone. I'm a board certified industrial hygienist with about 33 years experience, and I focus on indoor air quality evaluations in a variety of settings, schools, K through 12, universities, commercial office buildings, and even healthcare. In addition, I perform environmental infection control investigations for hospital-acquired infections, and I do Legionnaire's disease outbreak investigations and Legionella control plans. I often work collaboratively with architects and engineers for building moisture and mold evaluations and remediation, and sometimes I'm called upon to develop expert reports and provide expert testimony.
Okay, great. Well, thanks for joining us today, Harry. Last but not least, I'd like to introduce Leo Tram. He's a project director here at TRC. Hi, Leo. How are you?
I'm well, thank you. I hail from Milwaukee, Wisconsin, and my 30-year career at TRC has been focused on process improvements, the design of process and sanitary ventilation systems, and air pollution control systems to mitigate occupational and ambient exposure challenges. Thank you.
Okay, great. Well, thanks again to everybody for joining us today. So quickly, before we dive into the content, I'd like to just go through our agenda. First, we're going to talk about COVID-19 and routes of transmission, as well as surface cleaning and disinfection. Next, we're going to cover ventilation. Then we'll discuss indoor air quality. After that, we're going to talk a little bit about advances in the low-cost sensor field. And then finally, we'll wrap up with a Q&A. So again, feel free to submit questions at any point during today's presentation, and we'll get to them in that section. So at this point, I'd like to hand things over to Dave to get us started.
Okay, thank you very much, Christian. So what we'll do is start by briefly reviewing some of the biology about SARS-CoV-2. The virus is an RNA virus, and essentially what it does is it attaches to a receptor on the cell membrane. At that point, it's able to penetrate into the cell, and then it essentially hijacks the cell's metabolic machinery to reproduce itself. And when it's time to release, it actually takes a piece of the cell membrane and encapsulates itself, and it's released to the environment and expelled from the body in a number of different ways. The good thing about the virus is that it's an encapsulated virus, which makes it easy to neutralize with soap and water. But the thing that we've noticed here, particularly in the recent few weeks or months, is that there's new variants of the virus emerging. There's really three different modes of SARS-CoV-2 transmission. And they are, if we go back to the beginning, what we thought were the most prevalent forms were either direct contact from one person to another, which is identified here as number 2, or indirect contact with a person touching a contaminated surface. In the beginning, aerosol transmission didn't quite have the priority that these other twos had. And what we saw in the beginning was a lot of focus on cleaning and disinfection with not quite as much focus on air quality improvement. But what we've seen really since the summer is a shift in that thinking and the recognition that airborne transmission is in fact an important route of transmission and exposure. And what we have is really 3 different opportunities for testing SARS-CoV-2 residuals. First, we can look at clinical testing to identify infected individuals. We can look at surface testing to identify viral residuals on inanimate surfaces. And then finally, we can talk about air testing to look at the viral residuals in the air. And Harry will talk more about those in detail in his presentation. Well, the recommendations for cleaning and disinfecting that CDC published at the outset of the pandemic have really not changed much in the years since they've been issued. Basically, the focus is to clean surfaces with soap and water, and then it's got to be an ongoing routine process. The disinfectant should be applied only after the cleaning activity is performed. And then something that we've seen in addition to cleaning and disinfecting is how the workspace is utilized. In schools, the focus might have been on making certain that students sit at an assigned desk. But what we're seeing now in return to office is the same sort of approach with workspace assignments. And if there's organizations that have been doing the hot desking or office hoteling, they are incorporating some sort of procedures to address cleaning and disinfecting into those protocols. It's important to recognize that cleaning and disinfecting is really a 2-step process. It's important to take care of the cleaning step first because it really removes the dirt and grime and allows the disinfectant to work on the biological agent. It's important too that when we're using cleaning and disinfecting agents that they be both non-toxic and environmentally safe. The disinfection step is performed after the cleaning step. And in this step, we use either physical or chemical agents to destroy biological agents on the surface. And there's a couple of options. That can be a chemical application or it can be a physical application, something like a UV light. But if we're going to use disinfectants, they need to be on EPA's list in. And when you get the presentation, you'll be able to click on that hyperlink and find a searchable list to list in compounds. The key is to come up with a frequency that's both consistent and ongoing. The recommendations vary by locality and what the type of space is, but the key is that it's not a one and done type approach. They are continuing, consistent, and ongoing. One of the things that's important to recognize in developing and implementing a cleaning and disinfecting program is the importance of a record management system. It's important to use a system like this to maintain the schedule and track which areas have been cleaned, the materials that have been used to accomplish the cleaning and disinfecting steps, lot numbers associated with disinfections. And it's important to also keep these data in close to near real time as possible. That way you don't end up missing a spot or you don't end up repeating a cleaning and disinfecting activity. And in the end, this data management approach really provides an important part of a quality assurance program that demonstrates an ongoing and effective commitment to cleaning and disinfecting. And it also provides an opportunity to look at cost management practices and cost control procedures in the cleaning and disinfecting area. With that, I'd like to turn it over to Leo to talk about ventilation systems.
Thank you, Dave. Next slide, please. So a long-held approach to resolving potential occupational exposures in the workplace has been to apply this hierarchy of controls developed by the National Institute of Occupational Safety and Health in the 1970s. And starting at the top, these methods have proven most effective at reducing a hazard, but for obvious reasons, direct elimination or substitution are not always available, are not viable options for a viral hazard. Engineering controls, which include things such as physical separation, barriers, occupancy reductions, and ventilation, can provide the most effective measures towards reducing the risk of exposure. With regard to ventilation, one must consider the pathways or modes of transmission for a virus that Dave mentioned, and these include direct contact, indirect or surface contact, inhalation, and fourth, the airborne transmission pathway, or what we often refer to as the long-distance transmission pathway. Thus far, the evidence points to contact and inhalation as being the primary pathways of transmission, but that does not mean that we should rule out or do nothing with the ventilation systems in the spaces that we occupy. In fact, in most buildings, the ventilation systems are typically out of sight, out of mind until they don't work. Next slide, please, Dave. The ventilation systems in a building, or the air managed within a building, is the purpose of the ventilation systems are to heat, cool, clean, exchange, and provide humidity control of the building air. The cleaning and exchange of air is called ventilation, and clean air, in quotes, can be provided by one, the introduction of outdoor air, two, the use of air cleaners such as filters, or three, the use of air purifiers such as UV light. Mechanical systems can take many forms, and particularly in older buildings, these systems may not conform to current code or standards and are therefore not capable of high rates of outdoor air introduction or the use of high efficiency air cleaners. Often the mechanical systems within a space are controlled or monitored by a building automation system, which can be modified to increase the rate of outdoor air introduction or overall air turnover within a building. Next slide, please, Dave. Again, because evidence points to contact and inhalation as being the primary pathways of potential exposure to the virus, current public health guidance, such as the wearing of masks, social distancing, cleaning and disinfection, are of the utmost importance. However, the recommendations of the American Society of Heating, Refrigeration, and Air Conditioning Engineers, ASHRAE, form the basis for CDC's recommendations for ventilation systems, filtration, and air cleaning. ASHRAE's primary recommendations include confirming that the building HVAC systems are providing a minimum outdoor air introduction rate, supplementing those systems with a minimum MERV 13 filtration system, especially in recirculated air, and three, the supplemental use of standalone air purifiers with proven effectiveness and safety. Just a quick note about MERV. MERV stands for Minimum Efficiency Reporting Value. It is a scale of filter effectiveness established by ASHRAE. It ranges from 1 to 20, with filters in the 17 to 20 range being considered HEPA, or high efficiency particulate air filters, or ULPA, ultra low particulate air filters. And another note, there's a bit of a misnomer out there that the pressure drop through filters, higher grade filters, it can be prohibitive, that the systems are not capable of handling higher grade filters, that they would have a reduced air volume. That pressure drop is really dependent upon the construction and source of the filters. And in most cases, it is possible to retrofit a system with MERV 13 filters, and just additional attention to filter replacement will need to be made. Next slide, please, Dave. Other recommendations of ASHRAE include the implementation of zone or airflow pattern control within a space, extended system operating hours, and also, system inspection, validation, and essentially recommissioning. One key point in all of ASHRAE's recommendations is the maintenance of temperature and humidity levels within the space, humidity being particularly important with regard to the virus. And next slide, please, Dave. If through that inspection and recommissioning process, we find that the ventilation systems are not adequate, not up to code or standard, we do have options available to us to modify the system. And again, those options include things such as changing airflow patterns within the building, zoning, increasing outdoor air introduction, the addition of increased filtration and treatment of air, and the use of localized ventilation. And with that, I'll turn it over to Harry to speak to indoor air quality monitoring.
Thanks, Dave. Excuse me, next slide, Dave. So ASHRAE and the EPA provide guidance for certain parameters for acceptable indoor air quality. We've highlighted a few here for you today, and I'll explain how these might relate to COVID. So the first, carbon dioxide, is a byproduct of respiration. And if there's a buildup of carbon dioxide, it suggests that there may be insufficient outdoor air introduction or poor distribution or mixing of air in the occupied space, which is a very important consideration for COVID, as Leo had explained. Elevated levels of CO2 can cause lethargy, tiredness, or that feeling of stuffy air at the end of the workday. The next parameter, airborne particulates. So if we measure airborne particulates, both the size and concentration, it gives us an idea of the relative effectiveness of the filtration or a local particulate generation source. The next parameter, carbon monoxide. Since carbon monoxide is a byproduct of combustion, it can be from outdoors, such as vehicles, smoking, or fires, which are entrained into the building by the outdoor air intakes or negative pressure of the building. There also can be indoor sources, such as improper venting of a gas-fired appliance, hot water tank, or gas-fired air handling units. This is a good parameter to check in these COVID times, because buildings are often shut down for extended periods, and you want to make sure that these combustion sources are properly ventilated. The next parameter is volatile organic compounds, which can be found in perfumes, cleaners, and even copy machine emissions. It's an important parameter measure during these COVID times, as some disinfectants contain VOCs. And VOCs can cause irritations or headaches depending on what the concentration might be. The comfort parameters are temperature and relative humidity. And there's a bit of a disconnect between comfort and quality. Typically, when people are thermally comfortable, they perceive that the air quality is good, but that may or may not be the case. In these COVID times, relative humidity is an important part of the evaluation, because the virus, in layman's terms, is more buoyant, or quote unquote travels better actually in low relative humidity conditions. Next slide, Dave, please. So SARS-CoV-2 sampling, we can collect air, surface, and even wastewater samples. And the analysis is done by what's called PCR, which stands for polymerase chain reaction, where the PCR actually identifies and looks at sections of the RNA of the virus. The results come back either as detected or non-detected. They're not quantified. So the sample results do not tell us that there's more virus on this surface and less virus on that surface. It simply tells you that the virus is present. The other aspect of the PCR analysis, it also does not tell us if the virus is quote unquote alive or dead. Again, just that it is present on that surface or in that air sample. So air sampling can be done in high occupancy areas or critical security areas to assess the potential for airborne transmission. Surface samples can be done on high touch surfaces to evaluate cleaning effectiveness, and even on HVAC system filters to evaluate airborne spread. And that airborne spread might be a symptomatic spread, pre-symptomatic, or even asymptomatic spread. Wastewater sampling can help detect early indications of pre-symptomatic or asymptomatic occupants of a building or even in a community where you're measuring wastewater effluent for the presence of the virus. Next slide, Dave, please. So some suggested approaches on the indoor air quality monitoring includes conducting morning and afternoon measurements to try to reflect changes in occupancy throughout the workday or in specific areas of the building. Sometimes we see carbon dioxide levels rise later in the day as the building becomes more occupied. Now, later in the presentation, Dave will be discussing some sensor technologies where you can actually do continuous monitoring for these indoor air quality parameters. You also want to sample outdoors for comparison to the indoor concentrations and to determine if there's any outdoor influences on the indoor environment. Now, in terms of locations to sample, that'll really be dependent upon what your critical needs are in your particular building, and the survey can be designed to reflect that. Or you can sample by HVAC service zones to gather that information. Next slide, please, Dave. Now I'll discuss the guidelines for those indoor air quality parameters. Since CO2 is naturally occurring in our atmosphere and can fluctuate, the guideline is for indoors is the outdoor CO2 concentration in parts per million plus 700 parts per million. So in urban areas, sometimes the CO2 concentration is a little higher than maybe a suburban or rural area. So with the 700 plus the indoors, you typically end up running around 1,000 to 1,100, maybe even 1,200 occasionally. So thermal comfort is split between the heating season and the cooling season. The comfort range for the heating season is 68 degrees Fahrenheit to 75 degrees Fahrenheit, and 73 to 79 for the cooling season. Now, these ranges are designed to reflect account for that personal preference. Some people like it hot, some people like it colder. The guideline for carbon monoxide comes from the EPA's National Ambient Air Quality Standard, and that is 9 part per million. Regarding airborne particulates, you can measure size ranges, indoors versus outdoors, in particles per cubic foot for relative filtration effectiveness evaluation. And another method is to measure how much mass of a particulate is present per volume of air. And that unit is called micrograms per meter cubed of air. Regarding the volatile organic compound measurement, that evaluation is based on subjective human studies where individuals report the presence of irritation effects or headaches at various VOC concentrations. And then there's a guideline on a no effect level. If it's below that, you don't expect the occupants to have a concern or complaint regarding the VOCs. Next slide, Dave, please. So what are the benefits of performing this sampling? Just in a few words, it's a risk calculation for the ventilation system. And also with surface samples, it gives us an indication of, is the surface cleaning and disinfection effective at eliminating the virus? In addition, the independent air sampling helps confirm if there has been some HVAC modification that Leo discussed. If you do pre and post sampling of that HVAC modification, it gives you an indication whether or not it was actually effective or not. Lastly, the indoor air quality and the SARS-CoV-2 sampling helps boost confidence for reoccupancy of a building or continued occupancy of a building in these times of COVID. I'd like to turn this now over to Dave to talk about some emerging technologies.
Okay. Thank you very much, Harry. Well, what I'd like to do in this section is just talk briefly about what's happening in the ever-evolving area of sensor technology. And I'll start with really discussing what the attributes are of a generic air sensor. There's a number of different sensors available, but they generally share these 5 characteristics. First, the air is going to pass through the sensor. It might get that way through just passive diffusion type, or there might be some sort of device to move the air over the sensor element. The sensor then measures particles or gaseous constituents in the atmosphere. And then there can be some sort of algorithm that's on board the platform to translate that measurement into a concentration, or it might even adjust that measurement based on the measurement of another parameter to make a correction in the concentration of that measured parameter. The data then they can be stored internally. Typically, they're always stored on the sensor platform with periodic uploading to a cloud-based resource, or they can be downloaded at some later point if the sensor is not collected to a cloud. But there's a number of things happening in the sensor world, and this is just a very simple way of looking at how a generic sensor might operate. Low-cost sensors incorporate a range of different technologies, and what we see are very commonly the optical technology. Lasers are very important for particulate measurement. Photoionization is important for VOC measurement, and NDIR is important for CO2 measurement. Catalytic procedures are also used for VOC measurement, and in some of the comfort parameters, relative humidity is measured by capacitance and temperature is measured by thermistors. But this is a rapidly advancing and evolving area where there's new sensors being developed all the time, and the existing sensors are constantly being improved. Some of the general characteristics that are really helping shape this field are the size of these sensors. They're very small. They have a low power requirement so that they can be operated off of batteries, solar, that type of thing. And they're very inexpensive, with some of them is really maybe in the $9 or $10 range, going up to $1,000 in cost. And a really important aspect of sensors is that they come in a standard package size. And what that does is allow them to fit on a standard printed circuit board, which somebody can then customize and program to treat the data that the sensor gathers and upload it to a cloud-based platform. In the beginning, I think many folks in the indoor air quality area thought of sensors as really, toy type technologies, something that really didn't deserve much consideration. But we've seen a lot of advances that have really built the trust in sensor data, the information that's being generated by these various sensors. And that comes in the area of just basically the improvements in sensor technology, the new types of applications that are providing more reliable sensors. There's also significant improvements all around the area of just the technology of communications, data capture, reduction, and reporting. So much has happened in this area that's really worked to advance the performance and trust of sensors. Another important area is that we now see validation facilities for sensors where there's actual test beds where different sensors can be configured and tested and evaluated against reference methods or under controlled procedures. There's significant developments in the area of sensor use guidance. And then what we are seeing now is really firm protocols for the validations of sensors and how they are deployed and installed. But it's one thing to have a sensor. It's another thing to use the information that a sensor develops and then be able to act on that data. So what we're seeing is significant developments in the area of visualization of sensor data, tying that to alarm levels and communications so that people are notified of changes in the conditions in the built environment or indoor air quality. And then importantly, what we are seeing is that sensor technology is really driving significant aspects of building automation. I just got a couple of examples here of different sensors that are available, readily commercially available packages. But this is a diagram of the SGS LiveView cloud-based platform. And this particular image is some of their outdoor sensor applications, but they use the same sensors on indoor applications. But what you can find is a number of different ways of customizing the view that the sensors are reporting. You can provide different levels of access so that, you know, maybe building occupants see some screens, building managers see another, but it's a way of making the data transparent, but while allowing certain folks to have control over it while other ones may not. And then you can really drill down into these data sets and understand what's going on at very detailed levels. The SenseWare cloud-based platform is another very nice tool that's being used for indoor air quality measurement. SenseWare has a long history in building automation, use of sensors for building automation outside of the indoor air quality area, and they've really advanced their platform to help users understand what's going on in the building with respect to ventilation and concentration gradients across the floor plates. And then also, not only can you access it from your computer, but there's also a mobile application that you can use to view the sensor data. And this is just some very recent data that we generated for a transit authority, where we were looking at various indoor air quality parameters in two types of rolling stock assets. One had equipment in there to control indoor, to improve indoor air quality, and the other one did not. And what we did was we measured continuously over the course of 3 or 4 days and looked at the differences in a variety of parameters. But this just shows the differences in particulate concentrations for a controlled car and an uncontrolled car. And what we see is about a 20 to 25% improvement in particulate levels in the car that was equipped with the control equipment. So this type of information allows them to make assessments about the types of control technology that they might want to implement, as well as look at the performance of the control technology over time. Integrating this sensor data into building automation is really is where everything is going. And an important protocol is what's known as the Building Automation Control Network, or BACNET protocol for short. This is an ANSI ASHRAE standard. And essentially what the protocol does is it allows for seamless communication among a variety of different systems in the building and the information that sensors produce. So a sensor package that conforms to BACNET allows the sensor data to control building automation sensors. And so if we take some sensors, for example, that monitor key parameters like carbon dioxide and relative humidity, we can then use that information to control heating, ventilating, and air conditioning systems to achieve the target ventilation rates and relative humidity levels. But we still have a long way to go across the sensor spectrum to see that they enjoy the full benefits. So when we have really standards that address terminology, full range of sensor evaluation and performance classifications, how to properly deploy and cite these, how to acquire, process, and report the data, and then really an important area is what are the continuing practices for ongoing quality assurance and calibrating these devices. Once we have those standards fleshed out, we'll really see sensors achieve their full potential. But right now what we're seeing is there's really two leading sensor standards that are addressing indoor air quality in the built environment. And one is the reset standard, and the other is the well standard. And both of these address specific parameters and how the systems that use sensors should be designed and deployed. So I'll just wrap up this section with just a very brief summary here, but there's a wide range of low-cost sensors to measure just the full range of indoor air quality parameters of interest. There's multiple technologies available, and improvements in those technologies have really advanced the trust in sensor data. Sensors are automating building controls to improve air quality, and that is clearly the direction, the future, the way things are heading. And as we continue to see improvements in standards for sensors, we're going to see wider adoption of sensors for indoor air quality measurement and building control. With that, I'll turn it back over to Christian for questions and answers.
Okay, great. Thank you, everyone, for all that great information. We do have a couple questions today. First, I think this one's for Dave. How long does it take to put sensor-based IAQ monitoring systems in place?
Well, they can be deployed pretty quickly. So it's a matter of understanding what the building environment looks like, coming up with a monitoring plan, and deciding on how those sensors should be deployed. But really, you're talking 2 to 4 weeks from the time there's an expressed interest in a sensor package to getting a system installed, up running and reporting data.
Okay, great. Thanks. The next question is, why are humidity levels important to keeping the spread of the virus under control?
Leo, you want to take that?
Humidity is, just like a cold or flu, humidity levels in a building affect how susceptible we are to, the human biology and how susceptible we are to the virus. So good control of humidity, especially during the winter heating season, is important to reduce our susceptibility to viral contaminants.
And the relative humidity comfort range recommended by ASHRAE is 30 to 60%. So if at all possible, if you can keep that relative humidity in a building in the range of 30 to 60%, it'll certainly be effective at addressing the COVID virus.
And then I would add that, so the ideal range for is 40 to 60% for the minimizing the airborne transmission of coronavirus. But they tend to live longer if the they remain infectious longer if the relative humidity is between 20 and 30%. So that is an important aspect of building control.
Okay, so the next question we have today is, from a proactive perspective, what are the best times to conduct the IAQ sampling?
What we typically do is look at the measurements both in the heating season and in the cooling season, so you get different operational characteristics of the ventilation system. However, if you're using the sensor technology, you would have continuous monitoring throughout the year.
Okay, great. We have one more question. What are ASHRAE's requirements for air changes per hour?
ASHRAE uses different sets of units. The ASHRAE standard that we are referring to and the CDC is referring to is 62.1. And in there you'll find that ASHRAE suggests or sets a standard for outdoor air introduction and rates of cubic feet per minute per square foot of building, or cubic feet per minute per occupant or per person. And we can loosely translate those levels to total air changes per hour, depending upon the percentage of outdoor air introduction. Typically, the guidance is suggesting something on the order of 1 air change per hour of outside air and between 4 and 6 air changes per hour of total supply air. That's air that's returned on the return path for the air handlers.
Okay, great. Thanks. So we have a little of extra time and we did get a couple more questions. So we'll go ahead to those. How many monitors per square foot of typical office space given distancing requirements?
Well, some of those, some of the standards that I cited, they're talking about enough to cover about 80% of the workforce, or the folks that are occupied, or somewhere in the range of every 5,000 square feet. It's going to be facility specific, but those are the general guidelines.
Okay. We have another question. For surface testing for the virus, are there parameters to determine safe levels? If surface level data can't be compared against such parameters, what is the value of surface sampling?
Well, if you're surface sampling off a high touch surface, it's an evaluation of how effective the cleaning and disinfection is occurring. In other words, if you have a crew come in and are wiping high touch surfaces during the day, and you sample for the virus and you get a detect, it suggests that the cleaning is not effective, either in terms of the contact time of the disinfectant or frequency of the wiping of that surface. So that's one thing. If you're looking at sampling off some filters inside the HVAC unit and you have no reports of active COVID cases, it suggests that you have a asymptomatic carrier within the building. And that will help you tighten up on your social distancing, your cleaning, and masking requirements.
Okay, and then last, this is kind of more of a comment that hopefully you can give some feedback on, but are you aware of the recent ASHRAE study that delineates that enhanced outdoor air combined with MERV 13 filters results in the most cost efficient and comfort return for office spaces during COVID-19?
Yeah, that follows the general guidance of ASHRAE, and that is really the implementation that they're recommending.
Okay, great. Well, if anyone has any additional questions, feel free to reach out to us after the webinar. Again, we will be sending out a follow-up email that will have a link to this webinar recording, as well as a PDF of the slide deck. So please keep an eye out for that. And I'd like to thank all of our presenters today for sharing all this great information, and to all of our attendees for joining us for today's webinar. So hope everyone has a great week, and thanks again.
Thank you very much, Christian, and thanks to all those who joined today.
Thanks, everyone.